Hi everybody, here is Francesco Palermo, and I'm welcoming you to the Copernicus Marine Physical Asia training. Today we will focus on the global model, and we will see how to visualize maps of temperature, salinity, mixed layer depth, and vector currents. And we will see how to compute the density and plot vertical sections along the trunk set. Before starting, let's consider these two general notes. The first one is that for executing each cell, you need to click on the play button. You can find the button here for running the selected cell and advance. And please remember also that there's an easier keyboard shortcut, which is Shift plus Enter. And consider general note 2 that if for any reason the kernel is not working anymore, so you cannot proceed with the notebook execution, we found a problem, you can restart the kernel clicking on the circle arrow button here. Now let's see the table of contents. After the introduction, we will see the exercise number 1 for plotting the maps. We'll see the data, we presented the data, how to download them, and finally the exercise. We'll present the required models, Python models we used during the exercise, how to import them, how to access the data, how to set the configuration for the plot and the variables, and finally how to generate the maps for the physical variables. In exercise 2, we'll see how to plot the trunk sets. We don't spend more words about the data and how to download them because the data are the same in the previous exercise, and we will see the exercise, how to set and configure the plot, and how to plot the trunk set, the density, and the MLD. Introduction. The objective of this exercise is to use the CMM's Global Ocean model products and to visualize the main physical fields in the northwestern Indian Ocean. In particular, you will see how to display the horizontal maps of the different 2D and 3D variables, and the latter also at different depths for 2 different months, May 2020 and February 2021. The first one for the summer season, the second one for the winter season. And you will see how to plot vertical sections of physical variables such as temperature, salinity, and density along a trunk set in the northwestern Indian Ocean, and highlighting the vertical structure of these fields in these 2 different seasons. Exercise number 1, plotting of maps. A few words about the data. This example is based on the product whose identifier is Global Analysis Forecast FE 001024. Clicking on this link, you reach the products page on the Copernicus Marine Service web portal. Here is the page, where you can find all the information about the product, its documentation, the services for downloading the data. Let's go back to the notebook. The Mercator Global Ocean model provides 10 days of 3D Global Ocean forecast, updated daily. It provides daily and monthly mean files of temperature, salinity, currents, sea level, mixed layer depth, and ice parameters from the top to the bottom of the global oceans. In this table, you can find all the most important information about the product, its name, the geographical coverage, the variables, the spatial resolution, the vertical coverage, and more. If you need more information about the product, you already know the dedicated page for this product on the CMM's web portal, but also you can find detailed information in the document and product user manual, PUM. If you need information about the quality and validation of the product, you can consult the document QID, Quality Information Document. Now, let's see how to download the data. In this table, you can find all the information we used for downloading the data. The product name, the dataset name, the variable we selected, the product type, the geographical area, latitude and longitude minimum and maximum values, the time steps we selected, the depths. But how to download the products? The products are freely available, but you need the CMM's user credential. If you don't have already this credential, you can get them here. Clicking here, you will reach the registration page. So here you can ask for this credential. And with the CMM's account, you can finally download the data. During this presentation, we don't need to download the data because we have already the data downloaded and inserted inside the notebook. But in case you will run the notebook on your PC, you need the Motu client, which is the software needed for downloading the data, and it's a Python module. You can easily install the Motu client running this cell. I don't need to do it now because I have all the software already available. And for really download the data, you need to run these two different commands that permits you to download the data. You can copy the command inside the empty cell and run it. Please remember to set your username and password of CMM's user account. Now, let's go to the exercise. First of all, the required modules. We use different Python modules, many scientific libraries, such as NumPy, Xarray, Matplotlib. And we also use these particular libraries, which is GIBS Seawater Oceanographic Toolbox, GSW. Here is short descriptions, which allows us to plot the density. Here you can find some references about the Python code, its documentation. Before running the notebook, not during this training, but for your local installation, you have to check all the requirements. First of all, the Python version, that should be at least 3.7. You can check your Python version running this cell. I'm using right now the 3.7.3. And also you need to install Anaconda 3 and install all the listed modules here presented. After installing Anaconda and generate a new environment, we suggest to do it, you can copy this line in the cell below, empty cell below, and you can run it. I don't need to run it now because I said already, I have all the software, and we can go on. Install also the GSW package. After installing all the software, you can start with a notebook. You can import the modules. Now I'll go on the running the cells. Running the first cell. Running the cell for importing the modules. Gone. Don't change these codes because they are used during the notebook. Run the cell for load the function we use during the code, and go on. Set the path, create directories we need during the code, etc. Check if the directory have been created. You can see a list of directories and files, and if the data files are available. Yes, they are these two NetDF files. Now we are ready to access the data. Run this cell for accessing the data, for set the variable for accessing the data. Now open the data set. Set now the array index for accessing the desired dataset in dataset arrays. We select j equal to 0 for the winter, and but we also can select the j equal 1 for the summer. Run this cell, and let's start to get info about the dataset. Using this command, you will get all the info about the loaded dataset. So its dimensions, you can see depth, latitude, longitude, time, in which dimension we will have these coordinates, the list of coordinates and their values, the data variables we have inside the dataset, and some attributes. If you want more just information about the variables, you can run this command. You can see variables and their coordinates. As you can see, the mlots variable does not contain the depth coordinates, because these are 2D variables. The other ones are 3D variables. They contain the depth. Running this command, you get the coordinates. Go on. Let's consider the variables names. They are here. You can see that theta O is temperature, SO is salinity, etc. If you want more information about each variables, you can ask for it. So, to get info about temperature, run this command. You will get just the information related to that variable, so its coordinates and its attributes. You can see its long name is temperature here. It's the same for salinity, so if you run this, you get information for salinity. And the same for the other variables. Now, let's go to set configuration. I'll set the coordinates name, the variable's name, and we are ready to configure the variables for the plot. J equal to 0. Now we select the variable's plot. We have selected the mixed layer depth. You can see here the selection. If you don't want to plot this variable, comment it, and select, for example, temperature, which is the first one. Now, run the cell, set the limit for the area. I selected the full area, run the cell, set the minimum and maximum values. If you select none, they will be automatically calculated, and select the desired depth. Now we are quite ready to generate the maps. Configure the plot. You don't have to change anything right now. And now the real map generation. Run this cell and you will see your map. we selected the temperature for the February for the surface. Now, go back to the previous information we had. We can maybe choose to change the depth, because temperature is 3D field, but also we can also change the variable. So let's try to change the plot. You can change the variable, the area, the minimum maximum values, etc. Go back, selecting configure the variables for the plot, and then execute Excel for generating the plot. Now let's see how to plot the currents plot and display the monsoon current. We selected the J equals 0. We selected the full area, also in this case. The desired depth 0. Minimum maximum values. Here we selected the values. The skip points for the vectors. The vector scales. You can modify these values for changing the vectors behavior on the image. Now choose the variables to plot. We selected the variables related to the water velocity, and then finally run the cell for plotting the map. Just a few moments. That's it. We decided to plot the current's velocity for the February on the surface. Also in this case, please change the plot, change the time period, minimum maximum values and depth. Now, exercise 2, we can see how to plot transect of temperature, salinity and density. The data, how to allow them, are the same of the previous exercise, so we go to the exercise. Set the configuration. We selected the minimum maximum values for depth from 0 to 500 meters. We fixed the longitude point to 70, and we set minimum values for latitude -3, maximum values for latitude 30. So execute this cell and go on. Go on, don't care about this cell. And now this cell set all the variables we will plot, which are temperature, salinity, mixed layer and UO. Go on, set parameters for the plot. Go on, load the function used for plotting. And now we are ready to plot, for example, in this case, temperature. Go on, and you will see the temperature on the left for the winter and on the right for the summer. We will do the same for the salinity. And also for UO. Now, let's try to plot the density and do MLD comparison. Load the function used for plotting, and now you can plot the density for winter and summer. This is winter. You can see the density, but also the black line for MLD. And summer. You see the impact of the season and of the ocean circulation changes on the physical properties. The presentation has ended. We are going to the conclusion. Now you are ready to plot the global physical model provided by the Copernicus Marine Service, and for free, thanks to the European Commission. If you want, you go further and you can try to visualize other variables and diagnostic. We really hope you have enjoyed this session.